Good evening, everyone. So, this is week 10 of environmental chemistry problem solving session. So, here we will solve some problems and we can solve your doubt as well. Since there was some error in the recording of the session, so I am recording it again locally so that you can be benefited from these sessions. So, what we will do here is we will solve some questions, and in case of any doubts, you can put the doubts in the comment section or you can ask them in the next session. So, the question number one is there are few terms are given, which is, as you know, that oxidation reduction reaction, or commonly called redox reactions, are important type of reaction in environmental chemistry or any chemistry, to say. So, the reactant can be termed as oxidant or reductant, and the reaction can be oxidation for one set of reactant or reduction for other set of reactant. So here are some terms and the definition. What you need to is to match the following terms. So what is oxidation reaction? It means a compound is going from one stage to higher oxidation stage. So how that will happen? When it will donate an electron. So what is reduction reaction? When it accepts an electron. And what are reductant? It causes other compound to reduce. And oxidants, it causes other compound to oxidize. So we'll see the answer. So yes, A belongs to Q, B belongs to S, C belongs to R, and D belongs to P. So this is the solution. So let's take an example and understand this properly. Okay, so let's talk about one example. Let's take example of NaCl. Just say this is sodium ion, this is sodium, and this is fluoride. Just take a reaction. Okay, all of them has this oxidation state as 0. It is in elemental form. Let's see. Okay, and when they form salt, so they are in NaCl form. Here what happens? Sodium is in +1 state and chloride is in -1 state. Okay, so what we can say, sodium is losing one electron and gaining oxidation, gaining higher, going to higher oxidation state. So this is oxidation. And chloride is gaining electron or accepting an electron and going to lower oxidation state. So this is reduction. Okay, so in this case what will happen? This chloride will be oxidant because it is causing other compound to lose electron. So oxidant. Similarly, this sodium will be reductant because it is causing chloride to accept an electron or to reduce. I hope you understood this thing. There can be many other this kind of reactions. Let when magnesium strip, when it is combustion of magnesium strip, okay, when it comes in contact with oxygen, okay, this is in metallic form. Okay, metallic form, when it comes comes in contact with oxygen, it forms MgO. What happened? From 0, and this is because it is in oxygen form, so two gaseous form, so oxygen state is 0. And here what happens? Here it is in +2 oxygen state, and here it is in -2 oxygen state. Similar reaction will take place. Okay, so these are redox reactions. Moving towards question number 2. In a module video lecture number 47, when the instructor talks about the removal of arsenic present in water using redox process. Here we are trying to remove the dissolved arsenic by using redox process. Okay. Why it is preferred to convert arsenous As3 plus to As5 form. This is the reaction. Okay. So why it is preferred, like the AS should go from +3 stage to +5 stage. Why it is preferred? So these are the options. You can pause the video, think properly, and let me know the answer. So the first option is the removal involves redox coupling preferring higher oxidation state compounds. Means during removal, higher oxidation state compounds are preferred. Second is removal is independent of the compound present and both forms of arsenic can be easily removed. Third option is the arsenate form, that is As fifth form, is around pH 7. It exists in both the cases, both enabling ion exchange for further removal. So it is converted to these forms so that ion exchange can remove it further. So these are the options. Let's see the solution. The solution is yes. When this is at pH, when arsenate means As5 is at pH 7, it exists in these forms, 1 negative and 2 negative form. So ion exchange process can easily remove them. Okay. So just to ensure the removal by ion exchange process, it is converted from As3 plus to As5. Okay. Moving towards next question. This is also a match the following type question. We have to determine the oxidation number of the following compounds like carbon in carbonate ion, chromium in HCrO4, antimony in SbF6 1 minus, and carbon is C2H3O2, that is acetate ion. Please take your time to solve this question. We'll see the solution. So, like how to calculate oxidation state? Let's calculate for carbon in carbonate ion. Let us assume, like let's write CO3 2 negative, right? Let's assume for carbon oxidation state is X. For oxygen it is -2, right? And it is 3 times here, 3 times, and the total oxidation state of the compound is -2. So what will be the value of X? Will be -2 plus 6, which give us what? +4. So here the solution is A goes to Q. Let's go to option second, chromium. H is +1. Chromium we want to calculate, so X, and O4 is -2 into 4. -2 into 4, and the overall will be -1, right? So what will be the value of X? X will be -1 plus 8 -1. So X will be what? +6. So this will go R. Let's calculate for option C. SB, because antimony we want to calculate. So let's X. What is oxidation state of F? It's -1. So -1 into 6. What is overall oxidation state? It's -1. So X will be equal to +5. So this goes here. And let's calculate for acetate ion as well, just to be sure. And we have to calculate for carbon, right? So 2 into X plus 3 into 1 for H, and minus 2 into -2. So 4, which is equal to overall what? -1. Then X will be, or for carbon it will be -1 plus 4 minus 3 divided by 2. And what it comes? 0, right? So acetate ion will be this. Therefore, our solution is this. Okay. This is all the calculation that I have shown. So this is written nicely here. So you can refer this. Moving towards next question. Determine the correct statement out of the following. For monoatomic compounds, the oxidation state is usually 0. Monoatomic compounds means which is made of just one atom, like simple metal, Mg, or anything. The oxidation state is usually 0. B option is, in a covalent compound, the oxidation state of each atom is the charge remaining on the atom when a shared pair of electron is assigned to more electronegative of the two sharing them. Okay. Third option is, the covalent compound with two similar atoms bonded together like Cl2 or H2 has 0 oxidation state. The next option is, the sum of oxidation states for atoms in multi-atomic substances is 0 for molecules and equal to ions formal charge. So which of these options are correct in terms of oxidation states? We'll see the solution. So the solution is B, C and D. How? So for monoatomic compound, the oxidation state is equal to electronic charge. Okay. Like if I write Na will be, if I write Cl, Cl -1. Okay. So these are monoatomic. One atom is there, but oxidation state is equal to electronic charge. So -1 in case of chloride. In a covalent compound, the oxidation state for each atom is the charge remaining on the atom when the shared pair of electron is assigned to more electronegative of the two sharing them. Correct only? Next is, the covalent compound with two similar atoms bonded together has 0 oxidation state, right? The sum of oxidation state for atom in multi-atomic substance is 0 for molecules and equals to ion formal charge. Moving forward, question number 5 is, determine the reductant and oxidant in the following reaction. Please see which one is reduced and which one is oxidized. Then we can find out what is reductant and what is oxidant, and it can also be possible that this is not a redox reaction. So calculate the oxidation states so that you can determine if this is reductant or oxidant. So here the charges on chlorine is 0, and here it's -1, here it's -1, and here it's 0. -1, -1. So what is happening? Chlorine is reducing, chlorine is reduced, and iodine is oxidized. So it is oxidized, so chlorine is oxidant because it is oxidizing the other compound. And iodine is reducing chlorine, so it is reductant, as I have told or explained in the first question itself. We'll see the solution now. Yes, correct. Oxidant is Cl2 and reductant is I negative. Oxidant is a species that accepts electron, which means which itself is reduced, and reductants are the compound that donates electrons, which itself is oxidized, like in this case iodine. Next question is, find the number of H ions in the balanced half reaction of the following couple. So for this reaction we need to find out the number of balanced ions. This 3 will come here in the subscript. Please try to solve this question. Correct option is 3H plus. How? This is the full reaction. And we see that we need to find out H plus ions. This is the H plus ions on writing the full reaction. Okay. So now we need to solve the connected questions 7 and 8. FeCl3 is often added as a flocculant to water in water treatment plants. For the problem below, the FeCl3 is added to 10 raised to power minus 4 moles and assume that ferrihydrite is the only solid that forms. We need to solve this question in Visual Mintek. So we'll see the solution now. So we'll see question number 7 now. Determine the pH and dissolved iron concentration if FeCl3 were added to pure water. We have a molar mass of, we have moles of FeCl3. We know what solid will be formed. And so we need to determine the pH and dissolved iron concentration. Dissolved iron concentration can be equal to iron, okay, Fe2 plus and the complexes. Okay, so please solve this question in Visual Mintek. We'll see the solution. pH is 3.54 and Fe3 plus dissolved is 2.26%. Let's see how. So first of all, we add the values and run Visual Mintek to deduce solution. We have added compound name Cl and added 3 into 10 raised to power minus 4 as given in question. Because when FeCl3 will dissociate, what will happen? I'll write FeCl3 Fe 3 plus Cl negative. It will be 310. So if this is 10 raised to power minus 4, this will form 3 into 10 raised to power minus 4. That's why in Visual Mintek we are putting 3 into 10 raised to power minus 4. Now we will add it to the list. Now we will add how much Fe3 plus is there and Cl also we have added, everything we will add. Then we will add infinite solution phases. Okay, limitless to those species that can be formed based on components that have been defined. This is important to tick here, okay, otherwise everything will come. Then these are the compounds which will be formed, their concentration, log activity and activity. Then we will click to find out the percentage distribution among dissolved and adsorbed species. And Fe3 plus, how much we are seeing in form of Fe3 plus? This. 2.051%. And we needed to calculate pH also. So this is our pH. Coming to connected question number 8. If the water initially, at that time, question number 7, it was pure water, okay? Now, in this question, it is saying that water has alkalinity of 150 milligrams per liter SCaCO3 and pH is 8.3. In that question, the pH was 7. Okay, assume that all the alkalinity is from dissolved inorganic carbon. What are the pH and dissolved iron concentration at equilibrium? This can also be solved in Visual Mintek. We'll see how. So alkalinity we have to specify in this problem, which we are doing as 150. Okay. And after putting all the previous values, after that we will put alkalinity. This is the pH that we will get. Now, next two questions are also connected. These are the statement for those questions. The presence of iron in natural water has been known to create problems in potable water treatment and distribution system. The first thing, it will give color, right? So it is aesthetically acceptable, not acceptable when there is color, and it will cause some precipitation also. So that is why we need to ensure the aesthetic aspect, as well as we need to ensure the safety and integrity of the distribution system. So conventionally, water treatment plant use chlorination and aeration to remove iron in water. What will aeration do, or what will chlorination do? They will oxidize the iron to Fe3+. Then it will precipitate and it can be removed. It is proposed to use a strong oxidizing reagent like potassium permanganate. Following is the proposed reaction takes place when potassium permanganate is used. It is just converting Fe2+, which is in dissolved form, to precipitated form, Fe3+. So we'll see the question. This reaction needs to be balanced by using method of half reaction. What would be the number of H plus ions being in half reaction of Fe2+, Fe3+, and this respectively? So Fe2+ is converted to Fe3+. To balance it, we will just add one electron here. And we see there is no hydrogen involved. So answer will be from A or B. Oh, sorry. Coming to next part. MnO4 negative is converted to Mn2+. Here also we need to balance the oxygen as well as we need to balance the charge. So first of all, when oxygen is involved, we can balance it by using hydrogen. At the other side, we can form water. These things are very well explained in the classes. So number of hydrogen will be 8. So this is the balanced reaction, properly balanced reaction. MnO4 8H plus is equal to Mn2 plus. So how much H plus is given? 8. So this is your solution. Question number 10 is, in the finally balanced equation, how many moles of MnO4 negative would be required to oxidize 1 mole of Fe2 plus? So this can be calculated from this equation only. So simply zero point 0.2 will come. This can be easily calculated from equation 1 mole of Fe2 plus, like 5 to oxidize 5 mole, 1 mole of this thing is required, MnO4 negative. So for 1 mole, how much is required? When we do cross multiplication, X will come out to be 0.2. So that is your answer. So that's all for today. Thank you everyone. We'll see you in the next class.